Welcome everybody to our Sustainable Solutions for Small Fleets webinar today. And my name is Trey Pope. I'm with the North Central Texas Council of Governments. I'm an air quality planner. Also on our staff is Anthony Maffa, who will be working with the slides today. We have Juan Baron Luna. Both of those two are air quality planners. Juan will be our official note taker. And then we have Delaney Hankins, and she is our intern, and she'll be assisting with the technical side of things with our webinar. All right, next slide, please. So I'm glad to be facilitating and moderating today's webinar. We're going to have two presentations today. We'll start out with Juan Munju with amp control, and he'll be presenting, followed by Dr. Ann Shu. She's also she's the founder and CEO of ElectroTempo. And then towards the end, we'll have our final Q&A discussion, which we'll have one after Dr. Shu's presentation, and also after Juan Moon's presentation as well. And then we'll have our local updates and our closing comments. Just a quick word about one of our initiatives, which is what this webinar is based on. It's called SMARTE, which stands for Saving Money and Reducing Truck Emissions Program. This is an initiative which connects the trucking industry with emissions reducing and cost-saving technologies and strategies, which helps drivers, owner-operators, as well as fleet managers to reach their sustainability goals in a cost-effective manner. We work to build relationships with industry and local governments, also share information and resources, as well as to promote the use of smart way verified technology products. Now, our first presenter is Juan Munju. Juan Moon is currently facilitating business development at AMP Control, and he also engages in conversations with fleet operators, utilities, transit authorities, and solution companies on how organizations can electrify the vehicles and operate their EVs. Now we'll ask Juan Moon to share with us the role that charging management software plays in EV fleet operations, resulting in timely departures and saving on charging costs. All right.
Yeah, thank you, Trey, for the introduction. Really a pleasure to be here today. And so my name is Juan Moon. I'm doing business development at AMP Control. And a little bit of background on AMP Control. We are a charging management software focused specifically on fleets. And so what this means is that we're using real-time data to make automated EV charging decisions. So of course, for the fleet operator, they want to plug in their vehicle, their electric vehicles, and ensure that the charging occurs and that the vehicle is ready the next day. At the same time, maybe they want to save costs on the actual fueling costs. So maybe reducing the cost of electricity and optimizing the operations to ensure on-time departures. Yeah, next slide. A little bit more about our team. So we are a venture-backed startup. Our CEO and founder, originally from Germany, moved to the US around 3-4 years ago. And our commercial headquarters are located here in New York City. So I'm in New York. And we have actually a pretty global team. A lot of our engineers are all remote. So we have people really working on the software for electric vehicles in Europe, Germany. Our CTO is located in Finland. We also have engineers in North and South America, for example. And I think really we have a lot of projects throughout the world in various light to medium and heavy duty fleets, all focused really on this concept of fleet charging, monitoring, and optimization. Next slide. And really why the problems that we saw in the industry and why we created the software were three main things. So the first being high charger downtime, second, high energy and expensive power costs, and third, weak monitoring. So regarding the first problem, we see very high charger downtime. Let's say, for example, especially on the public charging side, you'll see many chargers are not working, maybe physical defects or broken components, maybe even like a software issue or maybe a payment issue. And so we see that, of course, on the fleet side, charger downtime is not necessarily acceptable or very costly for fleet operators. So of course, if you have a fleet vehicle, that vehicle needs to be out on the road to complete its routes. Maybe your customers, they can't afford to not have these sort of deliveries completed on time. And so we created the software to focus really on providing high uptime of the chargers. Secondly is the, of course, costs of fueling the electric vehicles, especially with the fleet. I'm sure that many fleets are trying to reduce or minimize all costs possible. Maybe some of the reasons on switching over to electric from diesel or gasoline is to reduce the amount of cost spent on operational side of things. So let's say reducing the costs of actually charging the electric vehicles by reducing the amount of time that you're charging on, let's say, expensive on-peak rates, charging when electricity is cheaper, overnight rather than during the peak, most expensive energy prices during the day. Also reducing power costs, so relating more to demand charges, which is the total electricity that you're using at a specific time of the day. So you can also save significant costs by shaving the total the power peak that you are facing with your chargers. And finally is just really increasing the visibility on all of your vehicles, all of your chargers, and your various assets, being able to see where your vehicles are along the road, being able to also see how your chargers are doing, let's say even receiving like a status update on whether vehicles are charging, whether vehicles might have any specific faults, for example. So next slide. And so what we've done, we've created a software that connects to various systems to monitor and optimize charging for electric vehicles. So we use something, a communication protocol, a very common communication protocol called OCPP. So we connect to the chargers through OCPP. We're also able to connect to additional components. Let's say, for example, the vehicle telematic systems. This way you can know where the vehicle is in real time. You can also figure out, let's say, the state of charge as it's completing its route. You may also deal with complex vehicle schedules. So integrating a scheduling or dispatch software for your electric vehicles so that we're able to charge the vehicles intelligently. So all of these charging decisions are done through the cloud with no additional hardware. And let's say we have information such as the vehicle has a 20% state of charge. Certain vehicles are leaving earlier the next day, other vehicles later. So the algorithms will make these charging decisions automatically, meaning that the vehicles that are leaving earlier will be charged first. The vehicles that are leaving later, maybe they're charged later. In addition, we're incorporating, let's say, the different energy prices or demand charges that you're facing at this site. So ultimately, resulting in a optimized charging schedule that ensures vehicles are able to depart on time while charging the most intelligent manner, let's say when electricity prices are the cheapest, and also reducing the total demand charges that you're facing on site. In this way, we are combining elements of, let's say, energy management system, a charging management software, and a fleet management software to help fleets electrify their vehicles, ensuring high uptime of their operations, and also optimizing their electric vehicle charging. Next slide. And so one of the things that we've also seen, of course, is to ensure high uptime of the chargers by making sure that the chargers are operational and being alerted for any any alerts or faults. So we also have a 24/7, 365 monitoring service where we are constantly monitoring the uptime of the chargers. We have a pager duty system that will automatically alert us in case certain chargers are down. We see, of course, a lot of the chargers. You're probably working with lots of different manufacturers, lots of different vehicles, and we're trying to aggregate all this data so that we can receive an alert, let's say a certain vehicle alert, maybe a specific charger OEM alert, maybe even something as simple as this vehicle is delayed and it won't be able to charge on time. But with all of these different sort of issues, from a software perspective, we are creating different escalation policies, different notification schedules, really that are customizable to each specific alert or issue. So for example, for a vehicle delayed alert, the fleet operator will get an alert for maybe an alert that says that the connector or the charger is broken. Maybe the facility manager will receive this alert. But really, we're trying to break down these different types of alerts by different categories, different urgencies, really to ensure that the fleet operations, of course, have very good uptime and very good timely departures. Next slide. So really a little bit on our trajectory. We're founded around in January 2019. We've had many customers since then and grew, of course, quite significantly. Some of our projects include being deployed at one of the largest publicly accessible charging sites in North America. That's actually in New York here with Revel, which I'll talk about more later today. We've also hit many milestones, such as thousands of charging sessions per month. We have various projects, for example, with a transit bus operator in the UK, a large trucking site with Watt EV in California. We also actually very exciting, signed a new project in South America at a very large bus site as well. So we really look forward to being engaged with fleet operators on electrifying their various types of vehicles, ensuring high uptime, and also reducing their charging costs and ensuring seamless operations of their fleet. Next slide, please. So really quickly here on the slides here, you'll see a dashboard of our software. So we're processing 7.5 million charging messages per month. So one thing that we've really aimed hard to do is increasing transparency across all the sort of different charger messages that you can receive. So these can include messages, for example, like a charging session has started, a charging session has ended, maybe also changing the actual power or the charging speed of the session while that vehicle is charging. We have a very high uptime, software uptime of 99.995%. Furthermore, we've tested with many different charging manufacturers. Many of the majority, the most famous ones out there, including Siemens, Heliox, ABB, Faihong, and we're of course also very open to testing with other manufacturers as well. So we're very agnostic on the hardware side. We connect through OCPP to these different charging brands, and so happy to work with whichever ones that you're of course looking at as well. And to talk a little bit more on the actual dashboard, here what you're seeing in the middle, you'll see as the images pass by, the red line decreases from 600 kilowatts to 400. And you'll notice that the black lines also follow the way that the red line is moving. And so this is how we're controlling the speed of the chargers in real time. So of course, this is an aggregate view, meaning that these are all the chargers that you have at this one site. So I think in this example is around 25 chargers, but you'll see here that the aggregate load of the 25 chargers are reduced almost in half. And so our software is making decisions on a connector level to ensure that your entire site power level is reduced in half. So if you wanted to reduce the peak at this time, or maybe the electricity rates get more expensive throughout this time, you can really make these sort of different charging decisions to ensure that the vehicles are charged while also following certain rules that you set to reduce the charging costs. Next slide, please. And so really to maybe go through a couple of different case studies of some of our work that we have with different fleets. We worked with Revel in New York, First Bus in UK, Watt EV in California. And you'll see, for example, with Revel, we're able to save around 55% on fueling costs. We do this by reducing the total peak and reducing and shifting the charging to an off-peak period. So reducing charging during the day, lowering that peak, and shifting it to when electricity is much cheaper overnight. So also with First Bus, which is a bus agency, a bus operator, we are ensuring 100% on-time departure of their buses following their, of course, complex transit authority bus schedules, while also accounting for dynamic energy prices. And so I'll talk more about these projects briefly afterwards as well. And finally, with Watt EV, they're operating large megawatt charging sites. And there we're monitoring and really tracking their hardware and vehicles to ensure high uptime of their operations. Next slide, please. So for example, with Revel in New York City, they operate an all-electric Tesla taxi fleet. So similar to the yellow cabs that you're probably well aware of in New York City, they have now these blue vehicles that similar to ride hail like Uber, except that they actually own the vehicles, also hire their own drivers. And they operate 25 tritium DC fast chargers, around 75 kilowatts each. So this is a very large publicly accessible site as well, meaning that the passenger public vehicles can charge at this site in Brooklyn, while also the private Revel fleet vehicles charge at this site as well. And so what our software is doing on the site, we're differentiating between public and private passenger vehicles. We automatically adjust the charging speed of the vehicles depending on whether it's public or private. We've also created a variable maximum capacity. So you'll see here on this diagram site power output, you can see the red line increasing and decreasing based on the time of the day. And you'll see on this diagram, the black line, which represents real meter values or power consumption values from the chargers. And so we're creating this sort of staggered variable power to ensure that charging is much controlled during the day and also increases at night when the majority of the Revel fleet vehicles to come to charge. And so by this way, we're able to save them quite significant costs on charging and operating their EVs. Next slide, please. And another project that we're working on is with Watt EV in California. So they have very large megawatt charging sites, up to 40 megawatts. And these are large trucking sites for drayage. And so here we're integrating, let's say, the telematics of the trucks so that we can track their real-time location, integrating their solar generation and connecting these with the chargers to be able to make intelligent charging decisions, while also ensuring, that, of course, very high uptime of their operations. Of course, no truck driver wants to come to that site and discover that some of the chargers are not working. Next slide. In addition, we're also working with Jackson County School District in Mississippi. So in particular, this is a school bus project. I'm sure if you're following electrification, especially in recent days, electrification of school buses is a very hot topic. And so we're working with Jackson County to not only ensure high uptime of the chargers and ensuring the operations of their EVs for their children, school children, but also to use the bus batteries during large events, such as like a sporting event, to use the battery of the bus to peak shave during a sporting event at their football stadium. So this would be V2B, meaning vehicle to building. So using the battery to reduce the amount of electricity that a specific building is using throughout that night. Next slide, please. Furthermore, we're also working, I think this is the last slide, we're working with ElectroTempo, which offers charging as a service. And so ElectroTempo is one of our customers, and they offer a variety of services from designing a site to real-life operations and maintenance. We are their software partner, meaning that they are using our software in their various projects. So these projects include, for example, Ferguson, which has a nationwide fleet, Vanderbilt University, which has a small bus shuttle service within their actual campus. We're also working with Duke Energy, a very large utility, of course, in the Carolinas. And so we're engaged in a variety of their projects with ElectroTempo, with different types of vehicles, most of them, of course, in a fleet setting. And yeah, next slide. I think that should be the end. But yeah, really great to have shared a little bit more about AMP Control. Of course, feel free to reach out to me through my email or ask question on this chat. I believe we have some time later on for any questions, and I'll be happy to answer. And also curious to learn more about how electrification is going with your fleet as well. But yeah, thank you very much.
All right, great. Well, thanks so much, Juan, for providing this valuable information on the benefits of employing this EV charging software, along with the case studies that you had demonstrated on charging software utilization. So I want to go ahead and quickly check and see if we have any questions for Juan Moon before we go on to the next presentation. Okay, so we don't see any in the meeting chat box. All right, so with that, we have our next presenter. It's Dr. Ann Xu. As I mentioned earlier, she's a founder and CEO of ElectroTempo. ElectroTempo is a software company that provides services based on electric vehicle charging software. And Dr. Xu will discuss the services that ElectroTempo provides in accelerating electric vehicle and infrastructure deployment time, as well as the challenges that fleets of varying sizes, including small fleets, face in various steps of the electrification process. Dr. Xu.
Thank you, Trey. Hi, everyone. A real pleasure to be here today to introduce ElectroTempo. We are, next slide, please. We actually have our roots right here in Texas. We are actually a spinoff out of Texas A&M. And our focus really is on the scoping side of electrification. So the key question that we're answering, our software tools answer, is to electrify or not electrify. That is the question. So that kind of precedes a lot of the interesting discussions that Juan just had. So our work and our current focus is more like for small fleets and for any fleets for that matter. At the very beginning, how do you even decide whether or not electric vehicles can meet my operations requirements? How am I supposed to get chargers? How am I supposed to get the chargers connected to the grid? How should I interact with both my landlord and my utility company? So those are the kind of questions that our tools answer. And we decided to do this because these are typically the questions that a large fleet or a large player would hire consultants to do, which requires a lot of money and a long time. And by doing this through software, our goal really is to democratize the expertise and accelerate the electrification journey for all. Next slide, please. So, like I said, our background, actually, my own background goes back to Texas A&M. That's where I developed the original, some of the original IP. My co-founder, Patrick Finch, and I, and also our CTO advisor, Suresh Rajagopalan, we actually met at the U.S. Department of Energy's venture arm, ARPA-E, Advanced Research Projects Agency Energy, where I directed a $15 million program called Transnet on transportation and energy. Saw firsthand what worked and did not work in terms of using software solutions for energy efficiency in the transportation sector. Decided to leave the government, went back to academia, to Texas A&M, and focused on developing software solutions to fill some of the gaps that I saw in the government. And then Patrick brings expertise from the commercial real estate and utilities side of the equation, where such that our company really comes together, becoming the bridge between the transportation sector, the commercial real estate, and the utility sector. Next slide, please. So what we are seeing currently is that the biggest obstacle facing fleets is the long deployment time, some easily stretching between 1 to 4 years. First, because the scoping study itself takes a long time for the fleet to get in touch with the utility partner to figure out whether or not the site can be energized. And then even if it can, typically the utility will take a long time for equipment upgrades. Next slide, please. However, what we've come to with our solutions, we can first and foremost cut down the scoping study time using software solutions. And second of all, through optimization, we can cut down the potential upgrades that's required from the grid side. Next slide, please. And the reason why it is so important to accelerate this timeline is that nationwide there is policy incentives and policy mandates that are putting pressure on the fleets to electrify. Most recently, there's the EPA proposed rule, which will start to take effect in 2027, which means it'll affect, start affecting the vehicles getting into the market mid-year of 2026, and that's not very long from now. Next slide, please. Before the fleets can electrify, charging infrastructure is the bottleneck. Next slide, please. And to address that bottleneck, fleets, as I mentioned earlier, needs to coordinate with the site host, who then needs to coordinate with the utilities. Next slide, please. And that's where ElectroTempo comes into play. And actually, in this on this slide, you can see our roots are originally in Texas. A lot of our solutions were actually inspired by our work with small fleets operating near and around Port Houston. You can see on the map there extending to the DFW area. And we actually have a project awarded by the U.S. Department of Energy specifically focused on truck electrification for the DFW and Houston mega region with the I-45 corridor in between. And our focus really is to link the three sides, the charging, the grid, and the fleet planning, to help fleets understand the scoping problem. Next slide, please. So with that, right now our product suite is mature and in the market on scoping analytics. We are launching procurement management analytics this year, so that as our customers move along in the in a electrification journey. We can help them select the exact type of equipment, the vehicles and the chargers that they should use. And then down the road, we would like to partner with folks like Camp Control to help with operations. Next slide, please. So how exactly do we do this with our software? So for the next 3 slides, I'll show you 3 different views, kind of touching on the 3 aspects that I mentioned earlier: utilities, sites, and fleets. So first off, utilities. How do fleets communicate with utilities, and how can utilities help fleets really addressing the problem of grid connection at scale? Right? This webinar is all about small fleets, and the big challenge of small fleets is it's not just about how much charging, how much power demand is likely to arise from the fleet's own operating site, but it also, perhaps even more important, to communicate to the utility partner how many other fleets are in the neighborhood that are also thinking about electrification and are likely to electrify in the near, medium, and long-term future, so that utilities can do their infrastructure planning. So our software has exactly that feature to show potential EV charging demand coming both from the passenger side and from the medium and heavy fleet side, to show the charging hotspots and allow utilities to overlay that on their asset maps to get ahead of the upgrade problems. Next slide, please. So along with that, the next step is really selection, right? Site selection. So if there are multiple potential locations for electrification, for powering charging sites, where should the chargers go? There's one part kind of coming from demand, and the other also is from supply. Which part of the electric grid has the hosting capacity? So that requires multiple layers of data. And not to mention that right now there's a lot of grants out there as well. So which sites are more likely to qualify for federal grants, considering all the demographics and justice, environmental justice considerations. So we have this feature that I'm showing here that compiles different data layers for site hosts on the commercial real estate side, or fleet owners that has controls over sites, to look at a portfolio of sites and quickly rank them in terms of prioritization for putting in charging infrastructure. Next slide, please. And then lastly, once you select a few sites, how do you decide what type of chargers, what type of vehicles, how many vehicles, how many chargers, how these chargers should operate, and what's the implication on total cost of ownership? And on that note, I'll have a few more slides to go in depth on this topic. Next slide, please. So we'll move on to fleet assessment and how our software approaches this at the scoping phase. Next slide, please. So first, let me take a minute to talk about what we see as the challenges, the unique challenges for smaller fleets. So as we all know, the EVs and charging infrastructure are expensive, and especially if grid costs are added. And that is often an underrated problem or challenge that a lot of times fleets forget to take into account at the beginning of the journey. And without software solutions to properly account for the different cost components at the very beginning of the journey, small fleets are less likely to be able to afford it, to a electrification solution. And so the key for smaller fleets is to, first of all, understand what the third-party charging infrastructure availability is. Some of the kind of solutions that Juan talked about earlier, like Watt EV or some EV charging hubs. However, when those options are not available, then smaller fleets are probably forced to consider depot charging still. And then looking at their own sites, it comes back to the challenge that I mentioned earlier, where when fleets go to the utilities to request a connection, it is beneficial to actually have some idea of the neighboring demand so that utilities can address the connection request and future-proof the connection request. Next slide, please. So with that, fleet electrification is actually harder than most people think, and our software solution accounts for the multiple steps in this challenge, going from first and foremost the basic performance requirements to meet the mission. There are a lot of times, especially for smaller fleets, it is very unlikely that the fleet operators will be able to switch to electric at wholesale. So for a long time, there is going to be a mix between diesel fleets and electric fleets. So how do you then schedule the routes and mission between the two types of vehicles? And then depending on the different mix, there's different site and property requirements. And that's the middle, kind of the feedback loop in the middle that you see, where it is very hard to do without software. Next slide, please. So to that purpose, we've designed our software to simultaneously address the financials, the routes, and the charging. So I'd like to kind of clarify here, right? Because obviously AMP Control, Juan just talked about how they can schedule the charger and control the chargers. That's not what we do. What we do is to look at the potential ways chargers can be scheduled, and how that matters in terms of electricity cost, in terms of total cost of ownership, feeding it back to the economic analyzer, so that fleet owners can have a comprehensive view of the different scenarios of total cost of ownership and payback on their investment. Next slide, please. So this is a bit of a gory slide to show you the detailed algorithm modules in our software, but I just wanted to kind of highlight the outputs, where with our software, we will run through multiple iterations, hundreds of iteration scenarios to identify the optimal mix of number of diesel trucks, battery electric trucks, the fleet operation reassignment, the charging schedule, and the resulting total cost of ownership, whether or not the non-grid options would make sense, and the emissions impact, which a lot of times makes a huge difference in terms of grant applications. Next slide, please. So to double click on the financial analysis toolkit, the key here again lies in the chart on the right, is that the total cost of ownership is not just a single point estimate. We will show a sensitivity analysis based on the annual mileage and other things like the available grants to show you the break-even point. Next slide, please. And then we'll also assign the routes so that you will understand, which part of my operations still need to be fulfilled with diesel trucks, assuming, and a lot of times it is true that third-party public charging options are not available yet. and which part of my options can be fulfilled with electric trucks, and how can I assign the routes to maximize my return on investment on these electric trucks. Next slide, please. So to give you a sense of why these iterations and optimization matter, this is actually a real-world fleet where we ran through multiple scenarios. I'm showing 5 of them. So you can see that only 2 scenarios that out of the 5 that I'm showing here would make financial sense in terms of reducing the total cost of ownership. So without optimization to assign the trucks, assign the chargers, assign the charging schedule, it is actually fairly difficult to arrive at a solution, solution package where electrification will save you the most money. So that is the challenge that our software is designed to solve. Next slide, please. So where do we go from here? I just wanted to put this out there that we are convening a industry advisory board, and we've done this actually already with a small fleet in the DFW area, and we'll continue to do so, where we'll provide free consultation with small fleets so that we can custom build solutions for you, because we understand there are a lot of solutions out there for large fleets, and sometimes large fleets don't even need a software solution, right? They have in-house capabilities, but there are a lot of challenges specifically for smaller fleets. Where to put sites, how do you meet all the range of your emission requirements with a few vehicles, and now some of them will need to be electric. So we'll be happy to meet with you and show you and custom build solution packages for your fleet. I have my contact information here, and happy to be in touch. Thank you very much.
All right, great. Thank you so much, Dr. Xu. We appreciate you providing this valuable information on how a machine learning apparatus can efficiently guide fleets through the electrification process, as well as the various scenarios that illustrate the metrics of this process. And so now I'd like to quickly check and see if we have any questions for Dr. Xu, as well as for Wenmin Zhu in the chat box, which I still don't see any. And Anthony, do you have any previously submitted questions that you'd like to run through?
Yes, Trey, thank you. So we have some previously submitted questions. These were submitted to us in advance of the meeting. So these questions are for both presenters, whoever may be. If you have an answer to it, if we want to just take turns, if you both have insight, that's fine. We can just go through a few of them as we have some time here. The first question, and I think this would be tailored more for Dr. Xu, but if you have insight as well, Wenmin, just let us know. But the question is, what is the first question small fleets have regarding electric vehicles?
And we would typically, in our conversations, I would say, would this make financial sense? How would this impact our bottom line? And how can grants help us?
Sure. Do you have any? Sorry, Trey, go ahead.
I was going to say, it looks like we got 2 questions in the chat now.
Okay, we'll go with those real quick.
So we have Michael Dobovo. So whoever would like to take this one. When using software to identify where to build a charging station, are you working with and current companies whose business focus is providing charging for outside fleets or public charging? And also, do you incorporate market research on anticipated commercial EVs being sold in particular markets? Whichever one of you two would like to answer that question.
Yeah, I can take that one. So yeah, we actually are working with companies, especially on the commercial real estate side, warehouse owners that have large portfolios of sites, to identify locations that are best suited to provide charging for fleets. And in that regard, what I'd say is that so the two key pieces of information we provide in this regard, one is an estimate of fleet operations density. So we have a unique algorithm to identify fleet depot locations. So these are not where the trucks are registered, but actually where trucks actually operate from. So we've recently done this. We've done this for the DFW area and for Houston under our DOE award, and we've recently done it in the Northeast for a large utility, so that they can so that the stakeholders understand where large concentrations of fleets are, and then from there we add on insights as to the arrival departure patterns at these sites, and also factor in the state-specific policy mandates and registration patterns to build, year by year, the anticipated commercial EV adoption in these markets, so that we can get an outlook of the power and energy consumption demands at every location throughout the region.
All right, great. I appreciate that. And our second question is from Maya Joyner to everybody. What are the benefits of adjusting the speed of charging, and why does it vary public versus private?
Yeah, I can take this one since it sounds like a optimization or operational question. So there can be several different reasons for adjusting the speed of the charging. Of course, if a fleet operator comes in and they just plug in the vehicle, the charger will provide it the maximum power available, or I guess the maximum rating that the charger can provide. So let's say with a DC charger, this could be like 50 kilowatts or higher. AC charger may be limited to 20 kilowatts. But really, let's say the first simplest way to think of it, if the vehicle arrives right now, but is not leaving for, let's say, 20 hours or 10 hours, there would be maybe no reason to give it the full maximum power right now. Rather, you could delay the charging to when electricity is cheaper and then increase that power. Of course, this would depend on how you're actually charged for the electricity. If you have a fixed rate and you don't have any energy, different energy prices or demand charges, maybe it would not necessarily matter. But if you have demand charge, you might want to charge more slowly over a longer period of time rather than more quickly in a shorter period of time. So all of this, of course, depends how you're charged for electricity, your actual fleet operations. But number one, I think the reason could be to avoid expensive energy costs or to avoid high demand charges. There could be also other reasons why you want to adjust the speed of the charging. With electric vehicles, sometimes charging too fast could damage the battery life of the vehicle. So maybe if you charge too fast for a short period of time, it overheats the battery, and so it can cause battery degradation. So we've had some examples in our projects where we want to cap the maximum charging speed of the vehicle for whatever reason. So even though you can charge faster, you will charge slower to reduce overheating of the battery. You might also have additional factors, let's say like a demand response program. The utility gives you a signal that electricity is very the grid is very strained at this specific moment, so you'll actually receive money to reduce the amount of electricity that you're using for maybe 30 minutes or 10 minutes, depending on the specific program. But there could be a variety of incentives on the actual cost side for you to reduce the charging speed, or maybe even increase it. And regarding the question, why does it vary between public and private? I don't know if this is like a specific question to the Revel example where I mentioned that the site is public and private, but in that particular example, we limit the charging of a fleet vehicle, or we slow down the charging speed of a fleet vehicle so that we can allocate the public charging and give that more power. So in that mixed fleet example where fleet and passenger vehicles are charging, we actually configured it so that we never slow down the charging of a public session. This is because a driver comes, they charge it for 15 minutes and leave. So they want to charge as soon as possible. So we always give them the maximum amount of power. Meanwhile, a private fleet vehicle, maybe we know when that vehicle is leaving, it's not leaving for another 5 or 6 hours. So we can afford to reduce the speed as long as we ensure that it's ready by the departure time. So you can really play around with these different settings. Maybe at a specific site, you have your primary fleet and you also lease out your site to the police department or the fire department, and you can have other fleets charging there as well. And so you want to prioritize your primary fleet, and then in case you have specific power limitations, you slow down the charging of other vehicles. And there's a definitely different a variety of different methods that you can employ depending on the use case. But the smart charging aspect, I think, of being able to control the speed of the charging will be very, very important, especially as the number of EVs grows. I think Dr. Xu talked about how there could be a lot of different power constraints at these different sites. You need to analyze how much power you have available, which vehicles to electrify. And so I think we'll increasingly see these smart charging use cases where you have to reduce the charging speed, not necessarily because it's an option, but because you have to reduce it to account for real life conditions. And this can include the grid, your actual fleet, or other vehicles that are charging at that site.
All right, great. I appreciate that. And thank you for answering those questions, Dr. Xu and One Moon. So to conclude this webinar, we'll have Anthony go ahead and run through some of the closing comments, and then we'll take it from that point.
All right. Thank you, Trey. Appreciate that. I'll run through these real quick here. So we want to just tell you guys about our smart vendor directory here, and we'll get into how you guys maybe can be a part of that directory as well, and why that would be beneficial. So when you become into our smart vendor directory, we will promote you through the smart program. It's free to join and it's free to use as well if you become a local vendor of the SmartWay verified technology. So how do you become a smart vendor? Well, you have to meet some requirements here. So you have to sell SmartWay verified technology, provide a list of the technology that can be made available so people can search for you. And then also you have to sign up, obviously, to complete that form here. So we have that link available on our website as well, I believe, Trey. If not, we can certainly send that to you if you email us. We also want to tell you about our Clean Cities program here. So the goal of the Clean Cities program is we want to advance economic, environmental, energy security, increase the efficiency, reduce emissions from transportation, partner with public and private. Also, we want to provide some fleet support, more efficient, greener fleets, match the vehicles and the equipment to that funding. We want to provide some training on some resources and those tools that are available. Plan for fleet transition. So if you want to transition to cleaner fuel, we want to tell you how to best go about that. So good practices and some tips and tricks as well. So, what do? We provide support, assist with navigating all these things, and we administer some funding as well. So the grant funding that we would administer that, provide technical assistance for that. We analyze the data. We hold webinars, much like we're doing today, workshops and things like that. We want to be like a one-stop shop for resources, best practices and templates as well. We do a lot of planning here. That's kind of the name of the game for our Council of Governments. We are planning for some of the alternative fuel corridors, zero emissions EV infrastructure, and organic waste to RNG feasibility studies. So we do a lot of studies as well. And so we do a lot of outreach and raising awareness and facilitating relationships. We also have National Drive Electric Week that is every late summer. We do organize some of that, and it gives everybody a chance, private companies and other governmental fleets, if they would like to join, to showcase, and also the public to showcase, some of the electric vehicle, cutting edge technologies and things like that they would like to show off. We also do some fleet recognition. So if anybody's got a kind of a standout program they're running, anything that kind of would show other maybe fleet managers, what is possible, and to kind of provide a resource to learn from, and also to just share stories and have other community events where everybody can come together throughout the year. So we have a national network of the Clean City Coalitions. We're not the only ones, but we're the one in North Texas. But you can see it's very robust. There's 75 of them, representing around 80% of the U.S. population. It's designated by the Department of Energy, and we work locally to try to promote all these fuel-saving technologies and other things. So there should be somewhere near you that has a Clean City Coalition. So it's a really good map. So here's how you can get involved. Of our website here, we have this on our website as well, all these other links, but you can see that we have some upcoming events. We have an email blast, and you can figure out how to become a sponsor as well. So please visit those links if you get a chance to check us out. And of course, here's our contact information if you want to get a hold of us after the meeting. So I appreciate it. Trey, head back over to you.
All right, thank you, Anthony. So with that, I'd like to say thank you to all our presenters and all our attendees for